Welcome to Net Change, Part 5. This one, I have 4 questions. And then I'm going to do a short podcast on just integrating in the calculator. So this is from the actual AP test. This was from year 2000. Water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of square root of t plus 1 gallons per minute for t greater than 0 but less than or equal to 120. At t equals 0, the tank contains 30 gallons of water. How many gallons of water leak from the tank, leak out of the tank from t equals 0 to t equals 3 minutes? This is a favorite kind of AP question where we have 2 things going on. We have something going in and something going out. So we're going to have to subtract what comes out and add what goes in, and we're going to have to integrate both of them. There's 2 separate integrals here. All right, so how many gallons of water leak from the tank? All right, that's an accumulated net change here. So you should be thinking we're going to integrate, and then we're going to evaluate. And we're going to have to integrate the both little parts here, the 8 gallons per minute and the square root of t plus 1. Oops, I almost hit the wrong button there. Almost stopped my tape. All right, so it's from 0 to 3 seconds. All right, so we have to do a little u du substitution. And we have u is t plus 1. All right, so the other part is pretty easy to integrate. So I just take care of this part here. So u is t plus 1 du dt. It would equal 1, and that means du is dt. I did change the limits of integration. So if u equals t plus 1, then t equals 0. All right, so, and therefore 0 plus 1 is 1. And when t is 3, part of that number got erased there, t plus 1 is 4. So my new limits of integration are going to be 1 and 4. So now to integrate this, right, I'm just going to have 2/3 u to the 3/2 and evaluated from 1 to 4. So that gives us 2/3 times the square root of 4 cubed minus square root of 1 cubed. So that's going to be, I have to my numbers here, 2/3 times 8 minus 1 is going to give us 7, 14/3. So that's how many gallons leak out from 0 to 3 seconds. Notice that's just the leaking part. All right, so we're going to get to the filling in part, because in another part of this question it's going to ask us for how much gallons are in the water. So this just asks for the how many gallons of water leak out from the tank. So that's just this part here. But don't worry, we'll get to the pumping in a moment. And then we'll have to combine them. How many gallons of water are in the tank at time t equals 3 minutes? So now we've got the leaking and the coming in. All right, so we have several things here. And we have the starting. The tank, so we want to know how many gallons are in. So remember, that's displacement plus starting. So I hope you caught that right here. So be careful. If it has an initial value, make sure you include that. So that doesn't get integrated. That's already there. We're adding that. So we have 30 plus, we have to integrate 8 dt. That's the pumping in at 8 gallons per minute. And then we have to integrate, but we already did this, square root of t plus 1 dt from 0 to 3. That's the leaking out. All right, so this is literally starting amount hopefully you're writing all this in your notes, plus pumping in minus leaking out. All right, so we already know the leaking out was 14/3 from the last page. And this is a simple integration. So 8 dt is just 8t. And then from 0 to 3, that's going to give us 24 minus 0, which is just 24. So we've got 30 initial, 24 going in, and then 14 thirds coming out gives us 148 thirds gallons. All right, so really take your time to think about these questions when you see them on the AP test, and think about how they were solved here. Okay. All right, water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of the square root of t plus 1 gallons per minute for 0 to 1 to, same question, by the way. In your notes, by the way, I did not write this 6 times, 4 times. There's 4 parts. 4 times. I just wrote it once and gave you all the parts. Right? I did each part separately here. That's why I have it written down 4 times. We want to write an expression for A of t, the total, and so this is an acceleration, but the total number of gallons of water in the tank at time t. And actually, we've kind of done that, except we evaluated. And here we're not going to evaluate. All right, so the expression for A of t is just our start. Looks a lot like the other page, except it says at time t. All right, that means that t is going to be your upper value. Make sure that 0 is your lower value because you add these all the accumulated. So start plus increase minus decrease. And then add this, right, because there was a time limit. This doesn't go on forever and ever. I guess eventually the barrel is going to be filled. And at that point, it's all going to be leaking out. There's going to be nothing going in. It's just going to be all leaking out all over the place, making a mess. All right, so that was a fast question to solve. It was really just what they'll be looking for. Do you have those right limits? Did you remember it's t and 0? And you remember 0 is the lower one. All right, and now same scenario. At what time t for 0 to t from between 0 and 120 is the water in the tank a maximum? Right? Justify your answer. So what are we going to do here? All right, so derivative is the rate of change. Absolute values occur at critical points or endpoints. So this is just like our, sort of like our curve sketching or optimization in a way. We were looking for maximums, right? So a maximum is going to occur at your critical points. All right, so, or your endpoints. Our endpoints are 0 and 120. To find your critical point, you have the derivative. You set the derivative equal to 0. So if it asks for a maximum, remember to find your critical points. And this is just your extreme value theorem. You're evaluating at the max, at the endpoints and the critical points. All right, so we set 0 equals, and don't forget the 8's part of it. We have 8 minus the square root of t plus 1. Add square root of t plus 1 to both sides. Square both sides. So now we have t plus 1 equals 64, and then t equals 63. Super easy to solve. And they probably won't be very difficult ones to solve, as long as you set it up right. So t equals 63 is a critical point, or the absolute maximum could occur at t equals 0. Not likely, right? Or t equals 120, our endpoints. All right, so now how to find, you just substitute back into the original function. I don't know if I did that on, I don't know that I think I did that on the next page. Yes, I did. All right, so we're just plugging back into our original function. All right, so, and now we got to find our original function, right? Because we weren't given our original function. So here we're getting our original function. So we're going to integrate 8t minus the integral of 8 dt minus the integral of t plus 1 dt. And if you remember from the other page, u was t plus 1. So that made this, we integrated this on the other page. 2/3 u to 3/2 plus c. I don't know how much they like the fact that I have t's and u's together, but I quickly changed it back. So in case it bothered somebody, f of t, I guess if u is labeled to be t plus 1, technically it is really in t's, but we got to substitute that back. F of t equals 8t minus 2 times t plus 1 to 3/2 divided by 3 plus c. We got to solve for c. We do know the initial condition. At the start there were 30 gallons. So we do have to get our original position, or I don't know if you call it position function, our original function for the water here before we can find our absolute values. So I just plug in 0 for all the t's and set it equal to 30. So now I've got 30 equals negative 2/3 plus c, and we'll add 2/3 to both sides. So 92/3 was my c, which means my equation is 8t, so the function whose derivative is up above there is 8t minus 2/3 t plus 1 to the 3/2 plus 92/3. So now we're just going to plug in our endpoints, 0, 63, and 120. And the winner is, on the absolute minimum, as you might have guessed, it's 0, the 30 gallons, because after that we're getting more water. And at 63 seconds, it's 132 gallons. It tops 120. Which means at some point the water leaking out is going to be greater than the water leaking in. And so that must be why that function. So it's not that it overflows. It's that it would be described by a different function, apparently, because the water leaking out is starting to overcome it. So the water is at a maximum at t equals 63 minutes. So just remember your extreme value theorem. If you're asked for a maximum, you evaluate at the endpoints and the critical points. Right? This is a nice little question. I think this is the best question in the whole lesson. Is this one right here? National potato consumption. The rate of potato consumption for a particular country was C of t equals 2.2 plus 1.1 to the t, where t is the number of years since 1970 and c is in millions of bushels per year. For a small change in t, the rate of consumption is constant. So the amount consumed during this time is C of t times change in t. All right, so we add up all those small amounts to get the total consumption. So that means if we integrate this is a rate of change. It's the rate of change in eating potatoes. And if we integrate it, we can find our total amount. And we want to find the total from 1972 from the beginning of 1972 to the end of 1973. Now don't use 1972 and don't use 1973 because this starts at 1970. So the beginning of 1970 means 2 years has passed, and the end of 1973 means, hello, it's 1974. So 4 years has passed, so now 4 years. So we evaluate that, so that would be 2.2t plus 1 over natural log of, I prefer writing 1.1 to the t over natural log 1.1, but it's the same thing. Evaluated from 2 to 4, it's a calculator problem. So 7.066 million bushels. Make sure you use the right units. It said that our answer is in millions of bushels. All right, so you can find the total of lots of things, including how many potatoes are eaten. Speedometer readings for a motorcycle at 12-second intervals are given in the table below. Use the data in the table to estimate the value of V of 18. We want the instantaneous rate of change at 18 seconds. So what estimates the instantaneous rate? What estimates the tangent line? What approximates the tangent line? I hope in your head you're thinking the secant line. The secant line approximates the tangent line. And we're going to have to use what values we're given. All right, so we've got 12 and 24. 18 is somewhere in between 12 and 24. So we can approximate the instantaneous rate of change with the slope of the secant line. So the slope of the secant line can be used to estimate the slope of the tangent line. I have seen that as a AP question before. So if you're given a question like this, you go to the two values that are one that's just less than and one that's just more than. Don't choose just any old values. Choose the ones that are closest to your value. So we have 18, 12, and 24 are the two closest values. So we just take the difference in the y values, 18 minus 22 divided by 24 minus 12, and we get negative 1/3. So that is approximately the value of the tangent line, right? And or the instantaneous rate of change in 18 seconds. Okay, so an easy problem, so long as you know how to set it up. And this is my last question. A supersonic jet accelerates at a constant rate of 150 feet per second squared until it reaches its maximum of 12, I believe that's a 1200, that's a horrible looking zero, 1200 feet per second. What is the maximum distance the jet can travel in 20 seconds if it starts from rest? We're looking for maximum distance, we're looking to integrate. And we're going to have to integrate twice because we're given acceleration, and we need to integrate the velocity curve. So we're going to have to integrate twice, right? We have to find the velocity curve to begin with, and then we're going to have to integrate the velocity curve. All right, so we have A of t is 150 feet per second squared. V of t is if we integrate 150 dt, all right, so that's going to give us V of t is 150 t plus c. We need an initial condition. We are told that the initial velocity, of course, is going to be 0, right? Before it goes anywhere, it's not moving. So that if t is 0 and v of t is 0, well, c is going to be 0 too, right? This isn't like sine and cosine. So v of t is 150 t feet per second. All right, so now if we integrate that, all right, now we've got to be careful here. We need to make sure that we know when it's increasing and when it's maintaining, right? Because it's gonna go until it reaches its maximum of 1200 feet per second, right? So we're gonna have to, I don't know if I put it up here somewhere, I'm looking. Did we somewhere set 1200 equal to our V of t? I don't know. I think it's somewhere. Oh, there it is. I see it. 1200 equals 150 V of t. Do you see that in green right there? So we have to find the limits of integration here because it's not going to keep increasing, right? So we don't want to use that velocity function for more than it's going to be true. It's only going to be true for 8 seconds, all right? So make sure you set V of t equal to 1200 because that's its maximum velocity. You know, it's a supersonic jet, it's not a rocket. And so that's only going to be from 0 to 8 seconds. So now we're going to integrate that part, and that'll give us part. That's the time it's increasing. All right, so we have, so it'd be 150 t squared divided by 2, which is 75 t squared, evaluated from 0 to 8. If I plug in the 0, it's going to be 0. So 75 times 8 squared gives us 4,800. That's the time it's increasing. And then it's going to be maintaining, right? Once it reaches its maximum of 1,200, it's going to stay there. So now for the rest of this, from beyond 8 seconds, minutes, whatever it is, seconds, then we're going to integrate the 1,200 dt. So be careful. This is a problem that's broken up into 2 parts, all right? Jot down notes and try and reason through and so that you can figure out how to solve these problems. And I can't show you every kind of problem that could ever come up, but I can show you some different variety. So if we integrate 1200, we get 1200 t. And now, why did we stop at 20? Well, because it said what's the maximum distance the jet can travel in 20 seconds. So from 0 to 8, we used the one function. And from 9 to 20, we use the other. All right, so it's maintaining 1,200 times 12 will give us 14,400. So, by the way, that's 20 minus 9 is going to end up being 12,000 times 12, right? If I plug in 12,000 times 20 and I subtract 12,000 times 9, I will have 12,000 times 12, I believe. Now I'm not trusting myself because this was up here beforehand. Let me double check. So 12,000, let's just make sure, times 20 minus 12,000 times 9 is going to give us 24,000. Put the 0 in the wrong spot, or a comma in the wrong spot. Minus, so that's going to be 10,000 times 9 is going to be 9. What does that look? Oh, because I'm missing, no, I have the right number of zeros. Oh, because I wrote the wrong number of zeros here. So that's going to be 9,000 plus another 1,800. So that's going to be, what did I say? 10,800. So why did I have 14,400? I don't know. Maybe I can't subtract. I looked at that and I said 20 minus 9 is not 12. Boop. I'm trying to fix my G. There we go. All right, so it should be, it's maintaining 12,000 or 1,200 times 20 minus 1,200 times, what is it about 12, about the 9? I want to put another 0 in there. Times 9, which is going to give us 13,200. All right, and so now just change this to 13,200, and that means that's going to be 18,000. Right? Yes, I think so. It's too late for me to remember. Yep, okay, so a little bit less there. We had a slightly wrong number in 20 seconds. So I think that's my last problem. And so I hope you enjoyed this and it made lots of sense to you. If you have any questions, let me know. And I think I'll do a real short calculator lesson. Actually, I can do the calculator lesson. I'm not sure I can tape the calculator lesson. I just realized that, because I can't have notebook up here and document camera at the same time. Well, if I'm able to do it, you will see a lesson in the same spot that says calculator lesson. And if I can't, I can show you on Saturday. All right, bye.